Hi everyone, welcome to Maths World. In today's video we are going to discuss about properties of integers, identity property. In the previous videos we have discussed closure property, commutative property, associative property under addition, subtraction, multiplication and division. In today's video we are going to discuss about identity property in integer system. Coming to the identity property, the remaining properties we discussed under addition, under subtraction, under multiplication, under division. Coming to the identity property, we will discuss only addition and multiplication only, because especially identity property and inverse property exists in addition and multiplication only. So these two properties are special. In general, if we add 0 to any integer, so what we will get? We will get same integer. So we can generalize that 0 is the additive identity for integer system. So now we are going to discuss additive identity. So if we take any integer a or any number, so plus 3 or minus 3, 3 is an integer. So minus 3, if we add 0 to minus 3, we will get minus 3. So minus 3 is an integer. Okay, so by adding 0 to any integer, we are getting the same integer. So in this case 0 is called additive identity of the given integer system. Okay, so by this we can generalize that there exists 0 in integer system. So by adding 0 we are getting the same integer. If a is an integer, so if a is an integer, so that is a belongs to z. So a plus 0 equal to a. So there exists 0 as a integer. So a belongs to z. By this we can generalize that 0 is an additive identity in integer system. Additive identity in integer system. Okay, so this is about additive identity. So now we are going to discuss about multiplicative identity. Okay, multiplicative identity. Only in integers additive identity, multiplicative identity we are going to check. Multiplicative identity. Okay, so like that additive identity, multiplicative identity also. So if we multiply in any integer with 1, we will get the same integer. For example, minus 2 is an integer. So if we multiply minus 2 is an integer. If we multiply minus 2 with 1, we will get minus 2 1 minus 2. Okay, we are getting the same number. Which number we have we taken? So we are getting the same integer. That means 1 is a multiplicative identity. So by this we can generalize that a belongs to z. If a is an integer, when we multiply a with 1, we will get a. A belongs to z. So 1 is called a multiplicative identity. So this is about identity property, means when we add any number, by adding 0 to any integer we will get the same integer, and then when we multiply with 1 we will get the same integer. Then 1 is called multiplicative identity in integer system. Can you guess additive identity of whole number system? Can you guess multiplicative identity of whole number system? So please post your answer in comment section. Okay, so overall we completed the identity property. Next we are going to next topic. So if in textbook page number 30, observe the following. So in general 0 is called additive identity. So page number 30 they have given minus 2 plus 0 is equal to how much? Minus 2. 5 plus 0 equal to how much? 5. 8 plus 0 equal to how much? 8. Minus 10 plus 0 is equal to how much? Minus 10. So have you given some examples? Complete the following. Try this page number 30. So 2 plus 0 is equal to 2. So like these questions they have given, please complete them. And similarly any whole number is added to 0, what we will get? Can you guess the answer? So please comment the answer. And next next we are going to discuss about distributive property. One more property of integer system, that is distributive property. Distributive property means, so if we take any three integers, so by taking three integers a comma b comma c, so belongs to z, so we can write it distributive property as a into b plus c equal to a into b plus a into c. So this is distributive property in integer system or any number system. So it is applicable or it is possible in integer system or not, we are going to check with by taking an example. A is equal to 2, b is equal to minus 3, c is equal to 1. I am going to check LHS. So a into b plus c, a means 2 into b means minus 3 plus c means 1. So 2 into minus 3 plus 1 minus 2. Okay, so plus into minus, minus 2 to 4. So LHS we get minus 4. RHS, so a into b means 2 into minus 3. So plus a into c means 2 into 1. Okay, so 2 into minus 3 means plus into minus, minus 2 3 is 6 plus 2 1s 2. So minus 6 plus 2 means minus 4. So RHS also we got minus 4, LHS also we got minus 4. So LHS equal to RHS. By these we can generalize that distributive property in integer system is possible. So by this we completed the 5 properties in integer system. So now we are going to discuss about identity. Okay, identity, I think identity we completed. Sixth one is inverse property. So in this inverse property also so we are going to check multiplication and addition. Inverse property and identity property, in these two properties are similar with each other. So in these two properties we are going to check addition and multiplication only. So first one is additive inverse. Additive inverse. So this is A, additive inverse. So what is additive inverse means? So if we add any integer to the for example we will discuss with example. Okay, a belongs to z, a plus minus a is equal to 0. So that is a plus into minus minus a minus a equal to 0. So additive inverse means a additive inverse means minus a. Okay, so sign is when we change no change in number, we are changing sign only. So if we take a is equal to minus 2, so minus a, if we add them, so minus 2 plus of minus 2, that is minus 2 plus minus into minus plus 2, minus 2 plus 2 equal to 0. We are getting the 0. So to a we are adding minus a. So we are getting 0. So 0 minus a is called additive inverse. So here it is minus a is called additive inverse of the integer system. So in inverse property, additive inverse is possible because positive numbers, negative numbers including 0 are called in integer system. Okay, next we are going to discuss multiplicative inverse. Okay, B, multiplicative inverse. So tell me, what is multiplicative inverse? Okay, can you guess the principle? Okay, we are going to discuss multiplicative inverse in integer system. It is possible or not. Okay, so by taking one integer a, that is a belongs to z, so a into 1 by a equal to a cancel, we are getting 1. So that is by taking example. So if we take a is equal to 3, 1 by 3 is the multiplicative inverse of the 3. So 3 cancel, we are getting 1. So we are getting 1, but 1 by 3 is not an integer. 1 by 3 is not an integer. So 1 by a is called multiplicative inverse, but multiplicative inverse is not possible in integer system. We are going to generalize the inverse multiplicative inverse. This is about additive inverse and multiplicative inverse property. Okay, so by this we completed the inverse property and identity property. So now we are going to generalize the or comparison of the additive inverse, multiplicative inverse, and identities, additive identity, multiplicative identity. We are going to make a table. So is it possible or not, we are going to write. Okay, additive identity, next multiplicative identity, next additive inverse, next multiplicative inverse. Okay, so tell me, additive identity, what is additive identity, what is multiplicative identity, you are going to answer me. Okay, so we are going to frame a table with this additive identity means. Tell me, what is additive identity? So when we add 0 to any number, we will get same integer. So that is 0 is called additive identity. Multiplicative identity, 1 means when we multiply any number with 1, we will get the same number. So next additive inverse means a additive inverse minus a, and next multiplicative inverse means a multiplicative inverse 1 by a. So these are the identities and inverse. So next in integer system, 1 by a is not an integer. So 1 by a is not an integer, that is multiplicative inverse in integer system is not possible. Okay, this is about deep explanation of integer system of properties. Okay, so in textbook we have completed all whole and soul properties discussion. So they have given some tables, you can easily fill them. So please complete them and write it in your plain notebook. So next we are going to discuss about fifth exercise, I think. Okay. So now we are going to generalize, or we are going to make a table with whole and soul properties of integers. So first one is closure property. Under addition is possible, under subtraction is possible, under multiplication is possible, under division is not possible. Okay, under division is not possible. Coming to the next property, that is commutative property. So under addition is possible, under subtraction is not possible. Under multiplication is possible. Under division is not possible. Next one is associative property. Under addition is possible. Under subtraction is not possible. Under multiplication is possible. Under division is not possible. Identity. Under identity we are going to check only addition and multiplication only. Okay, so division and subtraction we are not going to check according to the rules. So next identity under addition is possible. Okay, addition is possible and multiplication is possible. Inverse property under addition is possible, under multiplication is not possible. Why? Because we are multiplying a with 1 by a, so 1 by a is not an integer, that is 1 by a is not belongs to z. 1 by a is not belongs to z. So this is the whole and soul table about the properties of integer system. So by this we completed the properties discussion. So in 8th class also we are going to discuss this properties of rational numbers. So concept is very important, so that's why I discussed in each property in each class, each property in one class. So I think you understood well. If you like this video, please like, share and subscribe our channel. Thank you. Thanks for watching.